Alright guys, welcome to this page of the notes, and what we've done here is we're sort of coming to the last page in this section where we've been introducing ourselves to geometry. So what we've done so far is we've looked at sort of the way that you speak, write, and read geometry, okay, which is very, very important. We need to be able to communicate with each other, and so if at all you are unsure or still a little shaky on how you speak, write, and read geometry, please go back and re-watch some of the beginning pages of these notes where we talk about that. We need to be able to communicate clearly, so spend as much time on that as you need to. Then we talked a little bit about what distinguishes geometry from algebra. In algebra, you are generally given the problem that you're being asked to solve. In geometry, we're going to go one step further than that, where we're going to give you definitions, postulates, theorems, things like that, so that you can take a description or a figure and apply those theorems and postulates to help you solve the problem. We're going to get a lot more practice with that right here. So let's go ahead and jump into these problems. Again, hopefully what you're doing, at this point you're beginning to gain some confidence. You're trying these on your own and just coming back to check your answers with me. So if that's the case, welcome back. Let's go ahead and see if you got what I got. I want you to draw a diagram for each one shown. Again, what we're doing is we're practicing that language of geometry. You got to be able to speak the language, all right? And we're going to practice as much as we can. I tell you, AC, two capital non-italicized letters. So those are points, but the line above it with the arrow on each end tells me that this is line AC. So let's go ahead and draw myself a line. AC, there is point A. There is point C, and I have a line that runs through it. Now, I tell you that line AC bisects, well, we just talked about bisect on the previous page, bisects segment BD. All right, so we've got a couple of options here. All right, actually here, let me do this. I should have read the whole thing. I apologize. I should have read the whole thing before I started drawing. My bad. And I would suggest that. Make sure you read the entire statement before you start drawing your diagram. So let's read the whole statement. Line AC bisects line segment BD. So let's start with BD. Here's my line segment BD. Line segment BD, okay? Has two endpoints BD. Again, I could have done it the other way. Could have made that D and that B. We've talked about that. When it comes to a segment, doesn't matter. The order doesn't matter. Now, AC is a line that bisects BD. Remember, we just talked on the previous page, bisects means it divides it in half. So you have two congruent sections, okay? But there's a couple of ways to do this. I did not tell you that line AC is a perpendicular bisector. So here's what that means. You absolutely could draw line AC. There's point A. There's point C. Draw line AC right through there. And this tells me two things. In this case, I could say, hey, line AC is a perpendicular bisector, which means it makes a right angle with the segment BD, a perpendicular bisector. They're perpendicular to each other. They're at right angles to each other. And it's a bisector, which means those two segments are congruent. And I can show that by drawing the dashed line. But I did not tell you in the problem. So that's not wrong. That's okay. I didn't specify. That's perfectly a legitimate answer. If I had said AC is a perpendicular bisector, well then you don't have a choice. You must draw it so that they're perpendicular. But you could have also, since I didn't say that, you could have also done AC this way. A, C, and drawn line AC so that it runs through that midpoint, but runs through it at an angle. Guys, this line AC is also a perpendicular bisector. That point right there is the middle, which means it bisects BD down the middle. I have two congruent sections, but AC is no longer perpendicular. It does not intersect at a right angle. It intersects at some other angle that is less than 90 degrees. Less than 90 degrees. So, perpendicular bisector versus non-perpendicular bisector. If I don't tell you, there's a couple of valid ways of doing this. If I do say perpendicular bisector, make sure you draw a perpendicular bisector. They have to be at 90 degrees. So either one of those, perfectly acceptable. AC could be on a slant, or go and make it a perpendicular bisector if you want to. I didn't specify, it's up to you. It's up to you at that point. Oh, look at this. Oh, I'm so glad we did this. This symbol right here, you may or may not already be familiar with it. We've actually already talked about it. This symbol right here with the equal sign represents equal magnitude. The squiggly line above it represents shape. Magnitude and shape, yeah, you guessed it. That's what we talked about before. It means congruent. Remember, when we say two things are congruent, we are saying that two different things have equality. They're both the same magnitude. That's the equal sign, same magnitude. That's from algebra. You're comfortable with that from algebra. But the additional part to congruency is not only to have to be the same magnitude, they also have to be the same shape. And that's what that little squiggle above means. That little squiggly line above tells you that these things not only have the same magnitude, but they also have the same shape. So this is our symbol for congruency. It means that these two things are congruent. Same magnitude and same shape. So we talked about congruency on the previous page of the notes. There's its symbol. Whenever you see it, you know that that means these two things are congruent. Same magnitude, same shape. So let's go ahead and do that. I have HI, and IJ. Okay. J. And I tell you that they're congruent. So, same shape, they're both line segments, same magnitude, they both have the same measure, the same distance, right? So there you go. HI is congruent to IJ. Same shape, both line segments, same magnitude, they're equal to each other in magnitude, in distance, in measure. Those line segments, each of those segments would have the same measure. Use a ruler, they should measure the same. RT, that's a line segment, equals 1/2 PT. Well, that's another line segment. So here we go. Careful though, what this means is that you would have to take the line segment PT, divide it by 2, so cut it in half, and you would get the line segment RT. Well, let's start with RT. RT. There's RT. Is half of PT. Okay, well, I've already got a T in there, so let's go ahead and do P. And again, I apologize, I'm freehanding this. I'm going to try the best I can to go out twice as far. That looks to be about it to me. Hopefully that is it. So what I'm hopefully saying here is this. This distance right here, RT, is equal to 1/2 PT. If you were to take the distance PT, take the distance PT and cut it in half, that would be equal to the magnitude of RT. So there's a good description, a good drawing of that particular guy. Okay, hey, let's keep going. I got other stuff here for you. Let's see. What are we going to do in this one? Here's what I tell you. I tell you that Q is the midpoint of the line segment RS. Fantastic. 2 points are given. Find the coordinates of the third point. Great. So we're going to practice a little bit here using the midpoint formula. Let's do this. Line segment RS. So let's do that. I have R. I have S. And I tell you that Q is the midpoint, which means congruent. Those two segments are congruent to each other. And here we go. I've given you R, I've given you S. You know R, you know S. I'm asking you to find Q. All right, so let's find that midpoint. Midpoint is equal to, again, I like to make the point farthest to the left, x1, y1, the point farther to the right, x2, y2. X is 2, x is 4. This one's on the left, right? If you were to graph it, this one's farther to the left, this one's farther to the right. Okay, so let's go ahead and do that. So this is x1. Again, it doesn't matter. If you switch them, you'll get the same answer I get. I just do this for consistency purposes so that I always do it the same way. If you do things the same way, hopefully we avoid making simple mistakes. Okay, so this is going to be, remember the midpoint formula is x2 plus x1 divided by 2. So I would have 4 plus 2 divided by 2. Okay, comma, I'm finding a point, so it's comma, that's going to be my x coordinate. And then I need to find my y coordinate, which is y2 plus y1 divided by 2. So that would be 3 plus 1 over 2. Okay, so my midpoint is going to be 4 plus 2 is 6. 6 divided by 2 is 3. Hopefully you don't need a calculator for that, but if you do, don't fat finger something. 3 plus 1 is 4. 4 divided by 2 is 2. So my midpoint, which in this case is Q is at the point 3, 2. That's the midpoint of RS. If I were to plot these out on a coordinate plane, which feel free to do, please, if that helps you see it, if that helps you visualize it, do it. Anything that helps you, please use those visual aids. If I were to plot R, plot S, the point 3, 2 would be the midpoint of those endpoints, all right, right in the middle. Next one, I've given you Q, so that is the midpoint, and I've given you R. So here's one of those ones, right, where you have already been given the XY coordinate. This is going to be an endpoint. Let's go and call it x1, y1. So set up your formula where, right, you're going to have x is equal to x2 plus x1 over 2, and y is equal to y2 plus y1 over 2. Now, it's plug and chug. Plug and chug, don't fat finger something. I already know the x value. It's a -2. So -2 is equal to x2 plus a -5 all over 2. And then my y value is a -1 is equal y2 plus 2 all over 2. Okay, now, here we go. Really pretty simple algebra problem. Remember the order of operations, right? When solving, we're going to go the reverse, in the reverse order of operations. So order of operations says do everything inside of parentheses first. Everything inside of parentheses first. Then, after everything inside of parentheses, you would take care of exponents and radicals, right? Then multiply or divide from left to right. Then add or subtract left to right. That's the order of operations. When solving, you do the reverse of the order of operations, right? The reverse of the order of operations. So in this case, right, we're going to multiply the two to the other side first. So get that denominator out of there. So we'll multiply by 2, and actually, here, where do I want to do this? I'm going to just kind of drop down here. So that's going to give me a -4 is equal to x2 minus 5. Add the 5 to the other side, so x2 is going to be equal to 1. And then this one over here, I can just come up over here. -1, multiply the 2 to the other side, so that'll be a -2. That's a +2, so subtract it to the other side. -2 minus 2 be a -4. Let me switch those y2. So my answer then, right, don't forget to write your final answer. I'm looking for, I was given Q, the midpoint, and R, you found S. So S is at the point x comma y, 1 minus 4, right? And we did that by using the midpoint formula, but instead of solving for x and y, you were already given that midpoint x, y, and you're just going to use the midpoint formula to find the unknown variable, all right? Lots of algebra going on here. Stuff you hopefully have already done. If not, please get comfortable with this. You'll get lots of practice in the homework and stuff like that. Okay, hey, let's keep going. I got more stuff for you here. Actually, oh, shoot. Yeah, you should be able to, you can read this. All right, here's what I tell you. Line segment EC, line segment EC bisects line segment AD at point C. Whew. Lots of verbiage there, but you need to be able to read it and right? Understand the geometry. You need to be able to read the language of geometry. So we'll work on that. And line EF bisects line segment AC at point B. For each of the following, find the value of x and the measure of the line segment. Now, with something like this, I absolutely 100%, I'm going to draw a picture because it's going to help me visualize it. I would suggest that you do the exact same thing. Okay, here we go. I know that line segment EC bisects line segment AD at point C. Okay. The line EF bisects the line segment AC at point B. Whew. Lots of stuff going on here. Here's what we're going to do. I'm going to first do the line segment AD. So, here we go. Line segment AD. AD. There's my line segment. And here's what I'm told. That line segment AD is bisected. It does not say perpendicular bisector. It doesn't say that. It just says that it is bisected by EC at the point C. So, since it doesn't specify, you could really sort of do whatever you want to here. There's point C. There's point E. It's a line segment. And I tell you that that line segment EC bisects AD. So that means that these two guys have to be congruent to each other. So these are congruent line segments, and that's because EC bisects AD at point C. Now, in addition to that, the line EF bisects the line segment AC. Well, there's AC, right? At point B. Okay, so I have the line segment AC. I need to bisect, cut in half this line segment with the line EF, and that'll happen at point B. So the midpoint of AC, let's say it's right there. It's point B. Now I need to draw a line there and there, and that is the line EF. Go ahead and put F anywhere you want to. I'll put it down here, right? And so what I have now is the line EF, the line E. Oh, that's a terrible F. So I have the line EF bisects, cuts in half the line segment AC, and it bisects it at the point B. So you also know then that those two things are congruent. So AC is congruent to CD, AB is congruent to BC, C is a midpoint, and B is also a midpoint. I know, there's a lot there. We are going to get a lot more practice as we go through this course of geometry, but it just goes to show that we need to be able to communicate clearly, and that will require you to be able to read and understand the language of geometry. And practice makes perfect. Well, perfect practice makes perfect, but you're going to get lots of practice in the homeworks, the quizzes, the practice tests, all things that if you're taking this class with me, we will do prior to you taking the test. All of those are going to be opportunities for you to get practice doing this stuff. And the more we practice it, the better you'll get at it. So I got to be able to read this, draw a picture of it. All right, here we go. Let's just jump right into it. Here's what I tell you. I tell you that AB, that guy right there, and BC, ooh, that guy right there. I want to know what is AC. Hey guys, this is the segment addition postulate. I know that AB plus BC is equal to AC, right? That's what I know. They want me to find AC. But before I do that, right, I have these variables in there. I don't know what X is. However, I do know B is the midpoint, which means that AB is equal to BC. I also know that AB is equal to BC. So we're going to do that first to find x. Once I know x, I can then use that to find AC. So here we go. I have 3x plus 6 is equal to 2x plus 14. Again, I know that because B is the midpoint. It bisects AC, splits it into two congruent parts. Set them equal to each other. Subtract the 2 to the other side, which is going to give me x, right? 3x minus 2x is x. Subtract the 6 from the other side, and you will get 8. 14 minus 6 will be 8, so x is equal to 8. But that's not what I asked you to find. I asked you to find AC. Well, okay, we can do that. AB is 3x plus 6. BC is 2x plus 14. That's all equal to AC. Well, I know what x is, so plug it in, don't fat finger something on your calculator, and you should be good. 3 times 8 plus 6, 2 times 8 plus 14 is equal to AC, and AC again. Plug that into your calculator if you need to. Hopefully you don't need to, but if you did, don't fat finger something, and you get line segment AC is equal to 60, which is what I asked you to find. Right there. Let's keep going. Let's try another one. Again, using the description to draw a picture, and then I use the midpoint and the segment addition postulate. So the midpoint formula and the segment addition postulate to help me set up the problem that I then was able to solve to reach my final answer. All right, that's the way the geometry is going to work. We're seeing it over and over and over again. AD. I am given AD is 6x minus 4. I am given that AC is 4x minus 3. I want you to find CD. Okay. It looks like another segment addition postulate to me. I'm given this segment. I'm asked to find this segment, and I'm given the entire length. All right, well, we're going to find CD, but before I do that, please notice what you've been given. You've been given AC. AC. And you've been given the entire length, right? So how do I set this up? Well, AC is not equal to AD. They're very different lengths, and you can clearly see that. But you were told that C is the midpoint. It's the midpoint, which means that AC is congruent to CD. Well, since you know AC, right there, you know AC. If you were to take AC and multiply it by 2, you would get the entire length. And that's exactly what we're going to do to solve this problem. We are going to do 2 times AC. That will be equal to AD. Well, let's set that up. 2 times AC, which is 4x minus 3, is equal to AD, which is 6x minus 4. Hey, look at that. We got a distributive property here. Let's go ahead and do it. 2 times 4 is going to be 8x minus 2 times a negative 3 will be a minus 6 equal to 6x minus 4. Let me kind of shimmy shake out over here. Subtract the 6x to this side. 8x minus 6x would be 2x. Add the 6 to this side, so I'd have a negative 4 plus 6, which would be a positive 2. Divide both sides by 2, and x is equal to 2 divided by 2, which is 1. So I get x is equal to 1. But they want you to find, right, what is CD? Well, we know that CD is congruent. In fact, actually, let me put congruent to AC. I know what AC is. AC is 4x minus 3. Plug that in, substitute the value of x, cuckoo, cuckoo, you're all done. 4x minus 3, plug it in, CD is congruent to 4 times 1 minus 3. Seriously doubt you need a calculator for that, but if you do, don't fat finger something on your calculator. 4 times 1 is 4, minus 3 would be 1. There you go. Found that segment CD. So CD is congruent to 1. All right, I got another one for you here, 3. Again, hopefully you're trying these on your own, just now coming back to check your answers with me. Let me slide up here a little bit. Again, I got my diagram right here. I'll go ahead and do this one right down here. Here we go. AD. AD, that's the entire length, is 5x plus 2. BC is 7 minus 2x. I want you to find CD. Careful on this one. Careful on this one. I've given you BC and AD. Now, hopefully you see it, but follow me on this, right? I know that AC and BC are congruent. They're congruent segments. AC and CD. AC and CD, congruent segments. But I've been given BC, which I know is congruent to AB. AB. So if I take BC and multiply it by 2, right, I would get the segment AC. If I were then to multiply that by 2, I would get the entire length. So hopefully that you can see this segment BC is a quarter. 1/4 of the entire length. 1/4 of the entire length. So if I take and multiply the segment BC, if I multiply it by 4, what am I going to get? I am going to get the entire segment AD. BC is 1/4. I was given BC and it is 1/4 the entire length. And I know that because of this midpoint stuff. I know that AC is the same as CD, and I know that BC is the same as AB. So I just multiply it by 2, I get AC. Multiply it by 2 again, I get CD. 2 times 2 is 4. 4 times BC is the entire length. It's a quarter of the entire length. Plug and chug, guys. Plug and chug. 4 times 7 minus 2x is congruent to 5x plus 2. Here we go. Distribute. Let's see. We've got 4 times 7, so that's going to be 28. That's going to be a minus 8x congruent to 5x plus 2. Combine like terms. We'll add the 8x to the other side. That'll give me 13x. Subtract the 2 to this side, 28, 27, 26. 26. Solve for x. X is congruent or equal to 26 divided by 13. Hey, that's 2. 26 divided by 13 is 2. So now I know x, but that's not what I asked you to solve for. I wanted you to find CD. Careful here now. CD. Well, CD is congruent to what? Well, I was given BC. If I multiply BC by 2, I get AC. And I know that AC is congruent to CD, which is what I'm looking for. So here's what that tells me. This segment CD is equal to 2 times BC. This segment BC. If I multiply by 2, I get AC. But that's equal to CD. So we will simply go 2 times BC. Awesome. Here we go. CD is congruent to 2 times. My BC was 7 minus 2x, but I already found x. I know that x is 2. Plug and chug. Don't fat finger something on your calculator. I apologize. I am squeezing down here in the bottom. I am so sorry about that. 2 times 2 is 4. 7 minus 4 is 3. 3 times 2 is 6. All right, guys. Thank you so much for joining me for this set of videos. Hopefully at this point you are beginning to feel more comfortable with this introduction to geometry. We're beginning to learn the language. We're figuring out how to both describe a figure when it's given to you or take a description and draw the figure. And then what we've done is we've kind of been introduced to this idea of how geometry problems are going to work. You're going to use definitions, postulates, and theorems to help you take a description or a figure, to write the algebraic statement that you need to then help you arrive at the solution. We're taking a lot of the algebra that you have already done, right? Taking all that algebra brain stuff, but going one step further by adding some of these geometric relationships and components that are the definitions, the postulates, and the theorems that you need to know in order to help you solve the problem, right? For this one, you needed to know the definition of midpoint, and you needed to know the segment addition postulate in order to kind of piece this thing together to arrive at your solutions. And that's the way geometry is going to go for the entire year, and really sort of how these problems are developing our understanding of math and going a little bit farther, using a lot of the algebra you've already learned, but in addition to that, using these geometric relationships. Again, like I said, thank you so much for joining me. I had a great time with this. I'll see you next time.